Interesting. That sounds like grandpa left you a voicemail. Like
Zonos uses eSpeak for text to phone
I
conversion.
so for today's video, we are going to be taking a look at something that is hopefully a little more fun and less technical than some of my recent videos, and that is basically what we see right here on screen, which is called Zonos, and it is a leading open-weight text-to-speech model trained on 200,000 hours of varied multilingual speech. We can see that this is pretty cool. It is a recent release, and based off of some of the feedback and things we see here in their GitHub as well as their website, it is supposedly very performant, if you will, which means that it performs very well compared to other open source and apparently some state-of-the-art technologies existing in this space. Now, I have actually in the past done a lot of local text-to-speech testing, as when I was building my robots, one of the big things I wanted to be able to do was have a text-to-speech solution that would run offline. Unfortunately, back then, I couldn't really find anything that was very good that would actually run in the limited hardware I had, but fortunately, things have progressed, and we can see that while perhaps this is still a bit of a kind of barrier for some, this can actually be run in 6 gigs of video RAM or plus, which is definitely far more accessible than the typical kind of like you need a 24 gigabyte card to do it. And that is partially why for today's video, I am actually using my gaming laptop here. Now, I have said I will commit to actually showing the specs of what system I'm using in my videos, which I will of course do, but this laptop has a mobile 4060 GPU in it, which has 8 gigabytes of video RAM. So for the testing, we will basically just be using it on that card and seeing how it works. Now, there is kind of a bit of different options when it comes to actually installing this, but the cool and important thing is that there is a Gradio interface, which just means that we'll actually be able to use it through the web browser, though it will be running locally on our machine here. And if we scroll up, we can see that there are some other things, and I do just quickly want to actually go to their website right here and just take a look at kind of some of what they wrote about the release. We can see here that the beta release is titled February 10th, 2025. Today is the 12th. I do believe I heard about this a day or two before that, but perhaps I didn't. And we can see that this model has been released. There are 2 different versions, actually. There's a 1.6 billion parameter transformer version and a 1.6 billion parameter hybrid version. It does seem to me that it is not really quite clear what the actual fine-grained differences between the two are. There is no kind of simple description of this is what the transformer version would excel at versus this is what the hybrid version would excel at. But we can see down here that for those of us who are perhaps more technically talented, I guess you could say, there are some graphs and things like that, which do seem to indicate that the hybrid model is perhaps a bit quicker than the transformer model, as well as if we scroll down here, we do see a very pretty chart about the actual kind of training details and architectural details, and we can see there is a different kind of diagram for the transformer backbone versus the hybrid backbone. So there is some kind of relevant information as to what the difference is, but basically for today's video, we are just going to be trying the transformer one. As we can see, if we click on the actual Hugging Face link for this right here, we can see that the transformer one has 10,000 downloads as opposed to the 2.76 thousand downloads of the hybrid. So I suppose we can just go with the most popular one for the purpose of this video. We do also see that there are a few other cool kind of options here. Some of that is zero-shot TTS with voice cloning, which basically means that what it says right here, we can input a desired speech clip of 10 to 30 seconds, and it will hypothetically actually generate a cloned voice of that sample, which is very fun and cool, and perhaps touching on some of the more nefarious use cases of offline AI and things like that, or any AI really. We can see we have audio prefix inputs, which is basically the ability to kind of give it a starting point. So like you can start it off whispering and then it will continue in that kind of timbre or timbre, or one of those two perhaps. It has multilingual support. There is control for audio quality and emotion. Fast, which for us, we're not using a 4090, so we are not necessarily going to see those speed benefits, and a Gradio web UI and simple installation and deployment, which really kind of brings us to the next part, which is the installation and deployment. Now, I am actually going to be using the Docker installation section for this, as I did try this a few times using UV and then just trying pip instead. I did not have this playing too nice with my system, and I did actually go ahead and try it on the big PC behind me, and it was still kind of unhappy, so I just ended up using Docker, and for this, it actually seemed to work quite sufficiently. So we're going to just jump right into that. Now, before we get going with this, we can see that as one of these system dependencies here, we need to actually install eSpeak. And I suppose just as kind of a quick, like hyper quick history lesson, we can actually see the eSpeak GitHub repository. And if we scroll down here, we can see that this is actually a simple text-to-speech kind of program library. However, if we scroll down a little more, we can see that this actually dates back to 1995, which is really cool. And then this version was rewritten and enhanced in 2007 as what it's currently named eSpeak, which has obviously been kind of iterated upon since then. But it is just very cool to see how something here is actually based off of something that is 30 years old at this point at its kind of base. And it does tie into what I think is really cool about all of these developments kind of building atop one another as time has progressed. So to start off, we are just basically going to go ahead and install eSpeak, though to be honest with you, I do have to wonder if we can kind of just omit this, because we are going to be doing this all through Docker, so we likely do not actually need that, which is good. So we are basically just going to jump to the Docker installation. Now, of course, a prerequisite for this is that you will need to have Docker installed on your system and set up to actually utilize your GPU, which I am not really going to show in this video, but that is just something that you can probably find a lot of pertinent information online and things like that. And I should also note that as of right now, this only is set to work on Ubuntu 2022.04 and with an NVIDIA graphics card, though apparently somewhere they had written, I think it may have been on a Reddit post, that they were working on trying to perhaps widen the scope of what this can actually be run on. With that out of the way, we can basically go ahead and just clone this repository. And once we have done that, we are going to just change directory into the Zonos folder. And from there, we are simply just going to write docker compose up, which will basically go ahead and kind of pull the Docker image, and then also go ahead and once that's done, actually start the Gradio web interface where we can jump right in and start playing with this. So we can see that after about 500 seconds, or say like 9 minutes, this has pretty much 8.5 minutes. This has completed, and we can now see that we do have a local link, which you may be familiar with if you have run other things that have a Gradio web app to run them. And all we need to do now is just control and click on this, and we will be met with the actual Gradio web interface for Zonos. Now, when we do this, we are going to see that it is automatically going to actually begin to download the model file now. So the whole Docker setup and everything like that is not including the actual download of this model, which we can see is kind of happening now. So basically, we just are going to go back into here, and if we want to actually go to the Hugging Face page for that, we can get a better look at how big that is in terms of file size and things of that sort. So we are using the 1.6 billion parameter transformer model, which we can see is 3.25 gigabytes, and yeah, so that'll take a little bit of time. And if you have done this before, it will be cached on your system, so you won't need to re-download it every time you run the Docker container and things like that. But if you are doing it for the first time, it will need to actually go ahead and download the model. So we can now see that the model has loaded. The model, as we saw earlier, is about 3.25 gigabytes, so kind of big, but also not too big. We can see GPU utilization right here in NVTop is around 5 gigabytes out of 8. I am running OBS to screen record on this system as well, so there will be some overhead just performance-wise from that, and in terms of VRAM utilization and processor utilization, things like that. But we are now met with the web interface for the first time. It is really rather simple. We have our model to select, which for our purpose, we are going to use the transformer model. As we saw, that was the more popular download one from Hugging Face. So we could also select the hybrid model there, but this system does not have a lot of free space, so I will just stick with the one that's here. Then we can see we have the actual text to synthesize, which basically means that when we select generate audio right here, this is the text that it will actually turn into speech that we can then go ahead and play, which we will do right now if I make sure that the speakers are all the way up. truth be told, the speakers in this laptop are rather subpar. Even in Windows, like it's not a driver thing or anything like that. They're just pretty bad. So that's all right though. We can see it is taking a little bit of time.
Zonos uses eSpeak for text-to-phoneme conversion.
Okay.
Zonos uses eSpeak for text-to-phoneme conversion.
All right. She sounds a little like on a benzodiazepine, but aside from that, it's really not that bad. So I'm going to stick with the default one for just a second because there are some conditioning parameters here we see. Now, this is kind of one of the other things I was a little bit not concerned, but confused about is that these don't necessarily like have tooltips when you hover over them to tell you really what they are. So I know pitch right here, STD, will just make it kind of higher or lower pitch. So if we modify that and then generate audio again, we will see that there is a probably pretty significant difference in the actual pitch of the voice. So it'll sound much higher.
Zonos uses eSpeak for text-to-phoneme conversion.
That was honestly, that was painful to listen to. So let's just set that one back. Let's now drop it lower and try it again. Not 0, let's put it on 4. And that's why I'm just using the default text to synthesize right here so we can compare the different ones. But we will get into trying some more perhaps entertaining.
Sonos uses eSpeak for text-to-phoneme conversion.
So that is really cool. So kind of instead of just changing voice from like male, female, it just allows you to do it kind of here with some of the parameters. So we can see this sounds fully male.
Sonos uses eSpeak for text-to-phoneme conversion.
As opposed to the 45 value there, which was the default one, which obviously sounded female instead. So this is actually really kind of neat.
Sonos uses eSpeak for text-to-phoneme conversion.
Much more excited too. Speaking rate, I would assume, would be how many words are spoken per X time interval. So perhaps just speaking faster. Let's set that up and try it. Let me see if I zoom in just a little on this page. There we go. That's better.
Sonos uses eSpeak for text-to-phoneme conversion.
Faster, but also lower pitch. Interesting. Let's try that one more time with a lower speaking rate. Interesting. This took longer.
Sonos uses eSpeak for text-to-phoneme conversion.
Okay, maybe that one sounds like the benzodiazepine speaker, but okay, so Fmax hertz. I would assume that's like kind of a filter that it won't go above that specific frequency. Let's set it to something super low and see if it gets messed up. Again, that is totally hearsay. I don't actually know what this does, but that's just kind of my assumption based on my limited audio knowledge.
Sonos uses eSpeak for text-to-phoneme conversion.
Okay, yeah, that sounded a little more muted. Let me try it again way lower. So that seems like it just cuts the high frequencies out of the sound depending on the threshold.
Zonos uses eSpeak for text-to-phoneme conversion.
Interesting. That sounds like grandpa left you a voicemail. Like
Zonos uses eSpeak for text-to-phoneme conversion.
Some of the problems when I test these things on video is like I quickly go into like areas where I just get like banned off the platform because there's a lot of funny things you can do with these. So, all right, this is the last one I'll try here.
Sonos uses eSpeak for text-to-phoneme conversion.
CFG scale. I think CFG scale is just like how strictly it will adhere to the prompt, but I'm more used to that with stable diffusion stuff. Let me see.
Sonos uses eSpeak for text-to-phoneme conversion.
How hard to follow the text prompt. Okay, so I suppose maybe this would be for how... I don't actually really know what that one would be in this scope, to be honest with you. I'm not going to pretend like I understand that in the scope of TTS, but we can see, didn't really seem to... Let's set it really low. Ooh, we got an error. Okay, so we can't actually set it that low. All right, we're just going to leave the CFG scale to what it was in the default, and we're going to put min p back too. We're just going to leave all those. And now I am going to just quickly peek at some of the advanced parameters. This is probably like, I wanted this to be like...
Zonos uses eSpeak for text-to-phoneme conversion.
All right. Checking the box will make the model ignore the corresponding conditioning value and make it unconditional. Practically, this means the given conditioning feature will be unconstrained and filled in automatically. All right, we're just maybe going to kind of leave that one as is. But we can see we have some emotion sliders. All right, let's make the text-to-speech model perhaps a little upset. and also very disgusted. Not scared. And quite angry. All right. This could be actually kind of this could be interesting. Imagine having something like this, though, that was obviously far more efficient running on a little device.
Zonos uses eSpeak for text to phoneme conversion.
Interesting, but imagine having this in some form of actual gameplay where the NPCs have these kind of emotions but different and things like that. Obviously, the computational power required for that will be far more than what we have today, but maybe in 10 years or 5 years or 2 years, it is possible to kind of have a lot of cool options here. Let's check. Okay. Let's make it more happy then. And then okay, so sorry, I've been using this default thing here, which is kind of embarrassing at this point. All right, yeah, I don't know. We're just gonna, let's see. Let's generate audio here. I closed the advanced parameters. And then we'll try the voice cloning. Again, sorry if this is like all over the place, but I just kind of want to play with this on camera. So we'll do that. And then, just to give people a feel of how this is, there's obviously...
Oh man, this computer is crazy, and I am very happy to be playing with a beautiful 17 laptop.
Okay, so it didn't seem to do the inch as I put that there. That's all right. That was quite happy. Disgusted, huh? Let's make it kind of angry, and then we'll go ahead and we'll lower the pitch so it'll be like an angry, yeah. Not as surprised. I don't know what other is. Let's just turn other all the way up. Neutrality, let's make it perhaps a little higher. All right, and then we'll see. And then I'll try to do there are also other voices here that you can actually select. So I'll play with one of those after. Now, I know with Microsoft Azure, if you select a voice from a different region, it will just kind of still do English, but it will apply the accent of that region to the voice, which can be...
Oh man, this computer is crazy, and I am very happy to be playing with a beautiful 17 laptop.
To be honest with you, this actually... in certain...
Oh man, this computer is crazy, and I am very happy to be playing with a beautiful 17 laptop.
This really is not bad, and considering it is running within 8 gigs of video RAM, or less, as they say it will take, which is really quite cool. Let's, okay, let's try, these are perhaps a bit confusing. Let's try HT. I have no idea what that is. HT, yeah, we'll see. We can see GPU is being very utilized upon generations. It's at 100% utilization here. Power 53 watts. All right, let's...
Oh man, this computer is crazy, and I am really happy to be playing with a beautiful 17 laptop.
Okay. Let's see, what else do we have here? Let's do Scotland. All right, this will be... See, all right, I gotta stop. Sorry, I'm wasting your time, because I could just sit and play with this for hours, which, may speak to certain attributes about myself. But this is quite cool. So following this, I will just try to clone my...
Oh man, this computer is crazy. I'm very happy to be playing with a beautiful 17 laptop.
This is really quite fun to play with. All right, let's see if this will allow me to clone it. No microphone found. All right, well, that's going to be somewhat of an issue. So I will get a clip of my voice and then I will clone it. So I am now trying to go ahead and actually just do a clone of my voice with this. Unfortunately, I have not really been having good luck with this, between the Gradio web interface just not finding my microphone and this just not seeming to want to play with any of the different kind of file types I've actually made for this short clip. So I am just trying it with a wave right here. And we are just basically going to generate audio. So right here, this is where you would actually drag your cloning file. We can't see.
This is a quick test.
It's quiet, but if I play it, that is because the speakers suck on this laptop, but it does play in here. But when I go ahead and click generate audio, it doesn't seem like it's working too well. So, All right, so if this does work, I would say if you want to clone audio with this...
Sonos uses eSpeak for text to phoneme conversion.
All right, so I guess that is my voice. All right, let's play with this a little. Hold on a second. Oh, sorry, you can't... I forget sometimes when I'm on camera, like I need to maintain in this general location. All right, let's try this. Let's see. So you can see cloning does not really take too long at all. And I would believe you need to keep the actual file here for every generation of new text synthesis if you want to maintain having cloned.
Today we're going to be taking a look at Zonos, an open source text-to-speech solution.
I don't think I sound like that. Again, I may have used a subpar kind of voice clone thing, but this is just kind of me wanting to actually share this and just show kind of some of how it works and things like that and make folks aware of it, as I have not tested any really open source TTS stuff in a while, and I want to continue doing that just because for like the indie game devs among us.
Today we're going to be taking a look at Zonos, an open source text-to-speech solution.
I don't think that sounds like me, but again, I guess I can't really tell. Let's make me less happy. A little bit disgusted, quite angry, and a bit surprised. And then we'll see what happens. And we can see right here, video RAM usage is really not too bad.
Today we're going to be taking a look at Zonos, an open source text-to-speech solution.
All right, so not horrible, but again, this wasn't really a full kind of in-depth test to see how it compares and things like that. I just kind of wanted to do a sort of technical exploration of this. It is cool that you can do one-shot speaker cloning, and you would really likely get a better result if you had a better source file. So when it comes to voice cloning and things like that, kind of think of like in Stable Diffusion, where sometimes the actual text prompt heavily influences the quality of the generated result. That is essentially the same here for TTS, like one-shot speaker cloning. So having a really solid kind of voice clip to be cloned will produce a far better result in most cases. So overall, this was really kind of cool. And again, I did just want to do a simple video on this. I hope that it doesn't turn out too long, as it's more of just a, fun kind of thing. And I wanted to do it within 8 gigabytes of video RAM, as I know that showing things running on just 3090s and things like that can likely get a little tiring, because obviously not everybody has the capability to get a 24 gig card as it is. So hopefully an 8 gig card is just a little more accessible and palatable for a tech demonstration. With that, that is really going to wrap this up. So if you have any questions, please leave them in the comments. And thanks for watching.